Good morning, everybody. Welcome to Tibbetts Physics. What is crappin'? Today we are going to derive the acceleration formulas that are in your reference table. So hopefully we have a greater appreciation of where they come from and know that they didn't just come out of thin air. So what we're going to do is we're going to write down some formulas and then we'll label them so we could come back to them later. First one we'll do is our standard acceleration formula, which says acceleration is the change in velocity over the change in time. Whenever we do a change in something, it's always the final minus the initial. So really this is acceleration is VF, final velocity, minus VI over time. And what we want to do with this formula is solve for the final velocity. So we want to get VF by itself. First thing we'll do is multiply both sides by t. And that leaves us with a times t is equal to VF minus VI. So now we want to move the VI over. We'll do that by adding it. And our final answer is VF equals VI plus AT. And we'll call this Formula 1. Alright, so the next thing we want to do is look at old school math in terms of how we used to solve for the average velocity. So V average, if we have two different velocities, we'll look at V1 or V initial plus V final. And if we want to find the average of those two, we divide it by 2. So average velocity is initial velocity plus final velocity over 2. Now what we're going to do is take this final velocity from equation 1, right here, and we'll plug it in to right there. So we have average velocity is equal to VI plus everything that VF is equal to. So VI plus AT. VI plus AT. And it's all over 2, which comes from right here. Okay, so we have two VI, so we could combine those. So we have average velocity is equal to average velocity is equal to 2VI plus AT all over 2. Let's expand this fraction. So we have 2VI over 2 and AT over 2. So that simplifies to average velocity is VI plus 1/2 A times T. And we'll call this equation 2. Alrighty, so for our third equation, we're going to look at the average velocity formula in our reference table that we learned earlier. Average velocity is the change in distance over time. And all we want to do for this one is solve for change in distance. So we multiply both sides by t, and we're left with the change in distance is equal to the average velocity times time. And that's our third equation. Alrighty, so to finally create an equation in our reference table, what we're going to do is take the average velocity from formula number 2 and plug it into formula number 3. So the average velocity from here, we're going to plug it in to right there. So let's do it and expand it. We've got the change in distance is equal to average velocity, that's VI from equation 2, plus 1/2 AT. That's this right here, the average velocity, and we have to multiply everything by time. So let's just expand that. The change in distance is equal to VI times t plus 1/2 a. T times t is t squared. Now in our reference table, we just call the change in distance the total distance or the distance. So it reads distance is VIT plus 1/2 AT squared. And that's our first formula that we just derived. Okay, so for our last formula, we have to do some heavy-duty math, but I think we could handle it if we take our time. we're going to look at our first equation that we created. VF equals VI plus AT. So let's write that down. VF equals VI plus AT. And then we're going to look at the bottom equation. Average velocity is change in distance over time. We're going to solve for time first. So to solve for time, we multiply both sides by t. That gives us average velocity times time equals change in distance. But if you remember from before, the change in distance is just the total distance. So we'll get rid of that change in a second. And let's divide by average velocity. So we're left with time is the change in distance, just distance, over average velocity. So we'll take this and look at, we see a t in this equation, VF equals VI plus AT. So wherever we see a t, we're going to plug in d over average velocity. VF equals VI plus A times d over average velocity. Okay, now let's scroll up a little bit to our other formula we had. Average velocity is equal to VF plus VI over 2. So where we see an average velocity, we're going to plug in VF plus VI over 2. And we could draw right here so you can see what I'm talking about. All right, so let's do that. VF equals VI plus A parentheses distance. VF plus VI. Instead of putting over 2, I'm just going to make a fraction, so 1/2 times that. Okay, a fraction over 1/2 is just 2, so we have VF equals VI plus A times 2D over VF plus VI. Couple more steps and then we're done. Notice we have a number VI with nothing underneath, and then 2D over VF plus VI. So if we want to combine these fractions together, we have to multiply the entire thing by VF plus VI. So everything to the left of the equation sign and everything to the right of the equation sign. So that gives us, we're going to expand right here, the VF. So we have VF squared plus VF VI equals, we're also multiplying this VI with the VF plus VI. So we have VF VI plus VI times VI is VI squared plus A, this VF plus VI and this VF plus VI cancel. So A times 2 times D. Okay, so hopefully we can do some canceling. Notice both sides of the equation have a VF VI and a VF VI. So if we subtract the one on the left over, we're left with VF squared equals VI squared plus 2AD. And that's our final formula. So let's just look at all of our acceleration formulas at once so we know when to use them and when not to use them. The first one we have is acceleration is change in velocity over time. Change in velocity is really just VF minus VI, and the other equation we developed was VF equals VI plus AT. So first equation, second equation. These two are really the same thing. The second one is just an expanded form. Okay, so the third equation that we have is D equals VIT plus 1/2 AT squared. Third equation. And the last one that we just established was VF squared equals VI squared plus 2AD. That's the fourth one. Notice when we look at these, that each of these equations has a missing variable. So all the variables we have are VF, VI, A, D, and T. Look at equation 2. Notice that this one is missing D. So if you're not given distance in the problem, don't use equation 2. If you're given VF, VI, or T, use that one. Equation 3. Which one is this missing? This one is missing VI. No VI for equation 3. So if you don't have initial velocity, don't use this one. Look at equation 4. Which one is that missing? We've got VF, VI, A, and D. This one is missing time. So no time for equation 4. So if you don't know the time, don't use equation 4. And really quick, for the sake of completion, equation 2 has no distance. So each one is missing something different based on the information you're given. That's how you choose what to use. And that's it for me tonight, so see you next time. Have a great night.